So there are 5 pages of notes. We're going to get through what we can today. And then Thursday, I will be finishing up the notes. This first page is the pre-lecture page. So yeah, you can watch that and fill out these notes. If you did not watch the pre-lecture, some of the stuff I'm going to do, you're going to be going, where'd you get those numbers from? And it was trying to show you how to get the numbers from the periodic table. We are actually now going to work these numbers underneath the elements, which are the atomic masses. And so I'll leave that page for you guys to watch. And let's just do some problem solving. So you guys did amazing with math. I actually was really impressed when we did that lab 2. Some of you did amazing. Everybody struggles with it at first, and a lot of you yeah, realized you need to spend more time, and most of you did. You get a chance to redo the lab for more credit. And so again, that might happen to some of you with this lab 5, but I would do it. I think you guys can do it. The people who've turned it in have done really well. And after going through that study set, you also have your quiz due today. So the quiz is due today. The lab, you get some grace. You can turn it in late. All right. So this first question is really kind of takes the essence of what that video is. It is this concept of the mole. And so that's actually, I was just as a cat eye on, and now I'm a mole. Moles, apparently, I don't think they have ears, or they have these little slits, but I didn't want to blind myself because then I can't see anything. But it wouldn't matter because you're all black boxes. So I guess I'm seeing what a mole really sees, which is just darkness. But he sees the light in the darkness. That a mole of gold, gold is AU. And by the way, the abbreviation for mole is MOL. It's quite interesting. I talk about this on the video. Do not make up your own abbreviation. So either write the whole word out, MOLE, or abbreviate it. So I had a student who had a degree in English, and she just found this the most bizarre thing and everything. She was in my class for a full year. I don't know why they abbreviate it as MOL, but you're going to see me do it. I find it interesting. A mole of gold is what this number is, 197.0 grams. That's what those numbers mean. The word mole was short for the word molecule, but they are not interchangeable. But that's where the word came from, and that's the whole thing. You guys we missed mole day because we hadn't learned about it, and your teacher always misses it until somebody sends her a message. My other class, we actually had studied moles, so they got a special email. Yeah, that should be the bonus question, is when was mole day and why was that day mole day? And then to really get the bonus, you then have to send me something fun about moles. So they had to send me their favorite mole joke. So there you go. Now that we've studied moles, you get this week. You can send me your favorite mole joke. Somebody sent me the best mole joke I've ever heard. I'd never heard that one before, and it was, I'll share it on Thursday, but I'll see if somebody else. I had like 3 new mole jokes I'd never heard before, but you pretty much just Google chemistry mole jokes and you'll get a whole bunch. So after going through this lecture, they'll suddenly make sense. So the difference with this question is it's now asking about an atom of gold. And we're going to solve these doing the factor label that we did back in the first part of the term. It's not this long yet. That the key is that 1 mole, if a mole is this, a mole is also, I'll write it up here, 6.022 times 10 to the 23 atoms. It is a number like a dozen is, if you go to get a dozen eggs, you get 12 eggs. Nobody says, hey, go get me 12 eggs. They say, go get me a dozen. And so that's why a chemist doesn't say, hey, I need 6.022 times 10 to the 23 atoms. We call it a mole. So if you have a mole of anything, and in the video, I try to have some visuals in there for you. to get this idea, because this number is obscene. It's insanely huge. And that is because atoms and molecules are insanely tiny. And so it's something I talked about previously, like people, usually our classroom's right next to the planetarium, if we had class live, and everybody's always so excited when they're taking astronomy, and they're always like, oh, I have chemistry, and they're not excited. But chemistry is, you should be having a wow moment. And a lot of you wrote really cool notes on the exam. There was the question where you had to say what was one of the coolest, most amazing things you'd learned so far. And to me, this is always the most amazing, that if you have one atom, we're going to pull atoms to the bottom, and this number goes with the atoms, and it is our conversion. These are conversion factors. It gets us to a mole, and then 1 mole of gold is 197 grams, and we would punch it in. You could have 4 sig figs on this answer. I used the same notes for this class and my Chem 104 class, and so we made a decision in there to go with 3 sig figs, so that's why my answer has 3. The comments I would make to you in this class in 151, I am okay with 3 or 4 sig figs on this question. So either use Avogadro's number as 6.02 or 6.022. In Chem 221, we go with 4. So if you are somebody who is going to be going into Chem 221, just do it with 4. Use the periodic table with 4 sig figs. This is why my periodic table is so much better than everything on Google, because all the numbers on my periodic table had 4 sig figs. And then you had to learn the names, which everybody did, and they actually did better when they had to learn the names. My students were like geniuses. And so you guys can do that too. So if you had a 4th one, something to point out with this, probably the biggest technological glitch that students have is when they punch this in their calculator. If you're dividing by Avogadro's number, you have to use parentheses. A lot of you have to use parentheses, so you divide by both parts of this number. We're dividing by an astronomically, I mean, it's beyond astronomical. So if you listen to the video, you need like trillions of trillions of galaxies to get this many stars. So astronomy doesn't get anywhere near as wow as this does. Saying that, I go out every morning and every night and just have my wow moments staring at the stars and stuff, which at this time of the year is phenomenal because the winter constellations are amazing. So this is a negative 22. There is a negative there. It's hard to see with the font. And we should end up with a really tiny mass. Atoms are really small. Only gnomes can see them, and probably moles because they don't have eyes. So, and fairies. All right, this is, right, all of this is make-believe anyway. So we'll talk about fairy dust, which is silver. So this question says you have a sprinkle of fairy dust, which is 43.2 micrograms. So I'm going to write it as MCG. You can also write it, remember that funky M. This is a great opportunity to remind you that when you write microgram, it does matter how you write the M, because you don't want to kill anybody. So like those of you going into nursing or pharmacy, or going to be a doctor or a dentist, yeah, either write as MCG or the micro. All right. And that table that we used back on the very first lab with metric, that should be nice and handy. So you want things in this nice organized way, or back in the old days, they just learned it and they knew it, and so they weren't always shuffling through stuff. So the periodic table is grams. So if we have a prefix like micro or nano, yeah, and with moles, we do a lot with those metric prefixes. So microgram to grams. Just a reminder, I'm going to do it the way the chart was in the first lab. A microgram is a millionth of a gram. So that's how I use the chart. Again, if you like to say 1 gram is a million micrograms, that's fine. I just care that you get it right. Right, and then we're going to go from grams to mole. And so silver. We're doing silver now. Fairy dust is 107.9. So 107.9. And then 1 mole is Avogadro's number, 6.022 times 10 to the 23. All right, this one can only have 3 sig figs because I started you with 3 sig figs. A couple things with this. Avogadro's number has a unit. There's 2 units that we're going to use. One of them is atoms. So please make sure it has a unit, because if it doesn't, like on a quiz, you'll lose that dreaded quarter point each time that you leave the unit off. All right, this time we are going to end up multiplying by Avogadro's numbers, so we're going to get a really large exponent. Even in this is like a wee amount. You could not measure this on a scale. Even our best scale at school, you would not be able to measure this. And there's still in that little sprinkle of Tinkerbell's fairy dust, there is this outrageously huge number of atoms, right? A trillion is 10 to the 12th. Then a quadrillion, I guess, is 10 to the 15th. So this is like 241 quadrillion atoms. All right, who's counting? So now we're going to segue into compounds. So our first midterm, our first celebration of learning was about the periodic table, about atoms and the subatomic particles that make them up. What we're moving into for the next 3 weeks is the wonderful world of compounds, ionic and molecular. So we worked with that last week, how to write compounds. Now we're going to do the math with them. And then next week, we're going to draw them out as Lewis structures. All right. And then our last celebration is when we suddenly write sentences. So the first thing that we have to be able to do working with these is we have to figure out this number from the periodic table, the C27H46O. And this is what I talk about in the video. So I'm going to work this one through. I guess I have to do it with all of them. So usually I have my notes where I have all my answers on there, and I'm going to work it out over here just to show you. Usually I have a nice board. I can do it on the board behind me, but I do not need to see this math. I will know if you did it right when you do the setup. So I'm going to leave this space here to show you how to do that, but I'm going to go through the setup. So 3.14159, or some of you realize that's pi to the 16th power. That's a lot of pi. I made pumpkin pie yesterday. It's really good. I mean, actually, it was pumpkin peanut butter pie, pumpkin peanut butter banana pie. It was raw pie. It was really good. It's gone. There's no more of it. All right, you write the whole word molecules out. Do not abbreviate this word. I used to abbreviate it, and it was a disaster for the students. The students who abbreviate it end up getting confused with moles and molecules. So up here, I mentioned Avogadro's number gets a unit, and there were 2 units we would use with it. When you're talking about a single element like gold or silver, we use the word atoms with Avogadro's number, always to 1 mole. When we're talking about molecules, Avogadro's number goes with the word molecule. So when it's a compound, so 10 to the 23rd molecules. Yes, it's a big word. It's a lot of writing. The students who write the whole word out take the moment to write it. They end up getting it right, and we go to 1 mole. And then we pull the 1 mole down. So the mole, the key here is the mole is always a whole number. In this case, it's always a 1. We will run into where it could be a 5 or a 10, but it's always a whole number. It will have infinite number of sig figs. Avogadro's number is not exact. I talk about that in the video. And the periodic table is a measurement, so it is not exact. So that's going to limit our sig figs. So this answer, again, if you want to use 4, you can use 4 sig figs. So we need to figure out this number of grams. And this number comes from the periodic table. And again, that was the whole point of the video, because this is the key step. So we're learning about Avogadro's number, and then it's about punching it in your calculator. Just in the interest of time, you'll have to go back. I had a student last night. We did something different. We were doing gas laws, and it was only one student who stayed after, and she actually just wanted to go back and punch everything in her calculator with me present to make sure if she had questions, because there was one she had a question on. I would recommend you don't get the option to stay because I have to go somewhere after this class, but to make sure that you do take the time to go through this page on your own. So when you come to class Thursday, you're like, I've got this. I understand that. We're going to do more practice with it Thursday. Or that you have the clear question in your head. So again, don't come and say, I don't understand anything. You guys have been really awesome not doing that. And so I thank this class. That's one of the things, actually, I love 151 because students are never like that. By the way, your first box is empty. We can draw a pumpkin. You can have a face of however you want on your pumpkin. Did anybody carve a pumpkin? I did not this year. I actually stopped carving pumpkins because I like eating them too much. They're so good for you. They have really high levels of the carotenoids. So that stands for carrots, because carrots are orange. So anything that's orange, and so it's really good for the health of your eyes. And so actually making it yourself, you just throw it in the oven. You don't have to cut it or anything, and just let it bake for like an hour, and then it slices really easily, and you scoop it out, and you can make soup, pie, curry. You can have a pumpkin potluck with just a few friends. All right, so there are 27 carbons. There are 46 hydrogens. Omar, hopefully you were able to find this piece, and there's 1 oxygen. Now, the oxygen, I always put an X through my oxygen. I can put it on the screen too. Because otherwise students think it's a 0. This wasn't there either. We'll have to talk. Something must be funky there. Either that or you're looking at it weird. You know what, Omar? So this is something that I did, and I did it wrong. You don't click on it. It's actually there, like you don't click on the assignment. You actually, it's posted like right underneath the assignment. So if you go and try that now, maybe that's what you're missing. Yeah. All right, anyway, so we have 27 carbons, and you find carbon on the periodic table, and it is 12.01. So we're going to multiply by the 12.01. And that is atomic mass units, or it's grams per mole. It is not grams. This is something the lab this week. Yeah, there's a lab Thursday. I talk about this in the lab. It's a fine tuning. Grams are a mass you can get on a scale, and periodic table is the grams in 1 mole. So that pre-video talks about it some, and then the lab you're doing this week is to help bring it home. All right, hydrogen is 1.008. In the video again, and as I mentioned, you can do everything with 3 sig figs, so 12.01, or you can go with 4. You guys all have different periodic tables. Don't go with 6. It's not going to make it better. It actually usually makes it worse. So you can do hydrogen as 1.01 or 1.008. That's kind of up to you. Decide if you're going to be a 3 or 4 sig fig person. And then oxygen is 16.00. Now again, we're writing this out this time only, showing you where these numbers are going to come from that I'm going to magically have there. And then that pre-video walks through this in a little bit more detail. So the number of carbons, the subscript, times the number from the periodic table. And then we're going to add each one of these, plus the 46 hydrogen times its number, plus the oxygen times its number. And we just have to do that on our calculator. Yeah, Yeah, the storm must be coming in because it got a lot darker in here since I started. Did anybody get up and see the sunrise today? It was pretty phenomenal. Anyway, Damon, I don't know if you're here. He's telling me he likes sunrises too.
It was cloudy over here this morning.
Actually, it wasn't. I thought it was too, and then I happened to look out like a half hour before sunrise, and the sky was just bright orange. And so I live near the college, and if you go to the baseball field, you actually get a clear view of Mount Hood, and right now the sun is just south of Mount Hood. And so it was an amazing sunrise. I assumed I wasn't going to see it either because it was cloudy an hour before that, but yeah. Anyway, here it wasn't, right by the college. It was pretty amazing. When you have the clouds, the sunrise is even better. All right, so I wrote all the numbers down because I found the students love writing all the numbers down. You could go with 3 sig figs and round to 387. You could go with 4 sig figs. Did somebody else punch that in and got about that number? Oh, we're not done. My question wanted us to find micrograms. I also want to remind you, if you print, when you print, my micros sometimes don't show up with your printer, so it will show a box. So if you see a box, it probably means it's that funky mu sign. I've been trying to change all my stuff over to say MCG because of that problem. All right, and then you would go to micrograms and you should get my number there. And again, you could have 3 or 4 sig figs depending Avogadro's number. Mine should have 4 sig figs. All right, any questions? All right, so I am going to give you guys a moment so you can do one of 2 things. You can either try and do your setup, or you can at least say, hey, I'm going to add up these numbers and say, okay, at least now I'm going to get where she's getting this number from, the number of grams from the periodic table. So you can either set up your factor label or add those numbers up. So go for it. And if you're watching at home, you can like pause me and take a break. Or you can take a break. A comment I wanted to make, you can absolutely always figure this out and show your work. I never look at it. It takes up a lot of space, and it also takes up a lot of time writing it down. You should get to the point where you can just punch it in your calculator from looking at the 30 times the 12.01 plus the 4. So these are the numbers I got from the periodic table. So questions on how to get to that number? I would highly encourage every single one of you between now and Thursday to make sure you can at least get that number. And then if you do have questions, please come like 10, 15 minutes early. I'm here an hour early. I'm gonna go ahead and do the setup. Now, the one thing that's really nice about these problems, and my other class ended up doing really well, and in the past my classes have done really well with this, it's why we did that factor label practice before, was so we were familiar with the math, is I only give you one place to start. So you only have to have one piece. So you know where to start, because unlike on the exam where like one of the questions had like 6 pieces of information, you guys did amazing. Most of you got it. So there's my place to start. And then I like to write what unit I'm going to. So molecules. Again, I used to abbreviate it, and students will get confused with moles and molecules. All right, if you start with a metric prefix like nano, micro, milli, I don't know why all of these are micro. If you're going to write it as the mu, it looks like a U. You can write it as a U. It used to be a U. So micro is a millionth of a gram. So we put the 1 in front of the micro or the milli or the nano or the pico. They show up a lot. And then that gets rid of the micro. Now I'm going to change my gram to mole. So the whole thing on this page is the mole is a central unit in chemistry. It really is the central unit. And from moles, we can go all sorts of places. This term, we're only going to go between, well, there's only like 3 different places we go. Going between moles and grams, that's used in the periodic table. Going between moles and atoms or molecules, that's using Avogadro's number. So this is where the 456.7, I'm assuming my number's right. I know my answers, I'm pretty sure my answers are right, but if you ever get a different answer than me, please let me know. I don't know, maybe I'm more awake in the morning. My evening class, I make like at least 2 mistakes every class, and they very kindly let me know. And so it's probably not you, it's probably me. And then I pull the mole down and I go to Avogadro's number. Now, I want to show you something you can do is if you're like, oh my gosh, it's so long writing out that whole number, you can actually abbreviate it like this. And that is the accepted abbreviation for Avogadro's number. And in 221, we all end up doing it like that. Not all, but like 90% of the class. And that capital N and then sub A for Avogadro just means 6.022 times 10 to the 23. I actually usually recommend when we're first learning that actually writing the number out helps you to visually see it so you know on your calculator to use it. By 221, we become pretty familiar with it. So it's pretty much everybody reverts to writing the NA, but you can absolutely do it. You do have to have a unit after it. Now, another question that comes up, and we would get this answer. Now, again, you could have 4 sig figs, how I'm setting it up. I should have 4 sig figs. So I'll make a note. This should have 4 sig figs. I was doing it with my other class, and we decided to do Avogadro's number with 3. This one should have had 4. This one would have only had 3. This one should have had 4. All right. This is the other question I get from a lot of students is, why can't you just combine these 2 steps? And you could. You could go straight from 456.7 grams straight to the Avogadro's number and eliminate the mole. And if you like YouTube videos, a lot of them are going to do that. I don't watch any of them, so I find just doing the work, you'll get it. I don't combine them because of the next problem. There are other places we can go from moles. There are a lot of other places. And so there is, right here where my arrow is, we can fit another step in there. That step becomes awkward if we don't have the mole there. And that is like where we're going on the next page. And so that's why we're going to go to the mole, because from the mole, we can go all sorts of places, which from molecules. So we're not going to use Avogadro's number every single question, but we do on this page. All right, this next one, there's my starting point. So just since these numbers tend to be big and we have big words, you can just write hydrogen as H, capital H, and then atoms. And this one is a little bit different. We're going to milligrams, but we're not going to milligrams of hydrogen. We're going to milligrams of the epicatechin. Catechin? I don't know. It's in green tea. So this one has an extra step that is different from all the other ones. The first one, I was going from gold to gold. The second one was just about silver. This was just about cholesterol. This was just about whatever it was. Oh, the boswellic acid. All right. The good news is in this environment, your teacher's not breaking her shoulder, hurting her shoulder like she usually does. I just don't get to walk around and walk 10 miles a day teaching. That was probably an exaggeration. It's probably 9 miles. We have an extra step here because not only do we have to change the atoms to milligrams, we also have to change hydrogen to the epi thing. So first thing we're going to do is get to moles, because when you get to moles, you can do anything in chemistry, pretty much. So I'm going to pull the hydrogen atom down. So the key also with this question, this last question on the page, is we're working with 2 units. We're working with hydrogen atoms, and so we're going to change only 1 unit at a time. So we're going to go to hydrogen moles. I didn't abbreviate mole that time. You can. You can write the hydrogen before or after the atom. That doesn't matter. Sometimes I write it before and sometimes I write it after. All right, again, if you want, you can just write Na and then it's 1. Mole gets the number 1. Or you can write the 6.022. This time it's ending up in the denominator, like up at the top of the page. So parentheses with your calculator. You want to make sure you divide by this entire number. Right, that crosses out the atom. The step that we're going to do now is a mole-to-mole ratio. So the mole-to-mole ratio comes from the subscript. So this is the whole thing with what you did last week in today's study set. Those subscripts allow us to do math. Now, we're working with 2 units, so I don't want to just say mole. I'm going to say mole of H and then mole of the, I'm going to write the compound out this time, C15H14O6. For every 1 mole I have of the compound, I have 14 hydrogens. So that number is this number. It is an exact number, it's a whole number. Moles always get whole numbers. All right, now we just have one more step. So there you go. That's the mole-to-mole ratio. That's what those subscripts mean, that in this compound, there's 15 moles of carbon, 14 moles of hydrogen, 6 moles of oxygen. And then we do our 1 mole, 2 grams. So the 290.3, that was from the periodic table. It's not just the mass of the hydrogen, it's the mass of the whole compound. And then my last step is grams to milligrams. So either 1,000 milligrams on top, or if you're going with the chart, 10 to the negative 3. And we would only have 3 sig figs on this question. So there we go. Why only 3 sig figs on this one? My Avogadro's number has 4. My periodic table had 4.
5.35.
Yeah. So the original number actually determined our sig figs. All right. So questions with this page. It's really, that's why I had you that second lab where you did so much with the math. You guys have this pattern down. We're just adding another layer to it with really bizarre units, but they're really not that weird. And again, put the time in between now and Thursday. Thursday's lecture will then just hopefully fine tune it. If there's no questions, you can go to the next page. All right, so the next page, we're going to do this page. I'm going to do this page on Thursday. If you want, you can try it. You have enough stuff to do between now and Thursday, but the rainy weather's coming. All right, so we're gonna look at the next 2 pages. Yeah. So this is a question Stephen asked me because he's always a step ahead of me, it seems. Your lab this week is molarity. And so normally it's a really fun lab that you get to do, but since you're not allowed in the lab, which is like the safest place in Gresham to be because there's no one there, I actually videotaped myself doing the lab, and it does ask you at the end how I did because you're going to figure out my percent error, and I walk you through the calculations, and then you have to punch the calculations in, and then there's a lot of post-lab. But it is working with molarity, and what molarity is, it is symbolized by a capital M. And by the way, the joke with that is because Bill Gates' program also has no idea what molarity is, and he always changes my spelling very kindly to morality. And so you can think of it as morality. I've found in this online environment that I am really testing you more on your ethics than on chemistry. So it is a measurement of moles per liter. It is concentration. And in lab, it actually, this is the unit we use the most in a chemistry lab, is because things are dissolved. When you're working with an aqueous solution especially, so aqueous means it's dissolved in water. So ionic compounds and acids are mixed with water, and yeah, and that's what the lab is, just me going through making a solution and then analyzing it at the end. It's a very lovely blue color. So it's used in lab whenever we're doing concentration. Whenever something's been made up as a dilution. And why should you care? Well, you should care about everything because it is your life. You never know when you're going to get a job working in a chemistry lab. So it is actually extremely useful. It's another use of moles. And this time it's our conversion. It is like when we did density. It's not the same as density because density is mass per volume. It is always how many moles in 1 liter. It is specifically per liters. So let's go ahead and just do this first one. And again, watching the lab, a couple students in my other class were a little confused because I pretty much set up all the math for you. All you have to do is copy down what I do, or you can pause it and try it yourself and then see if you got it. And then you just have to punch the numbers in. I didn't have my calculator with me. All right, this one has 2 pieces of information. It has grams and has milliliters. So having a colored pen is really helpful, underlining or circling or highlighting the information given. And we also need to know the compound. So the question wants us to find what is the molarity. Yeah. And rather than writing it as a big M, the biggest hints I can give you with this page and with the lab is you want to write it as moles per liter. We're doing factor label, we're doing unit conversions, and the unit is not big M, it's moles per liter. Again, we're not doing it as the diagonal slash, we're doing it as a fraction. If I am solving for 2 units, I have to start with 2 units. So I'm going to start with the grams on top. So 23.456 grams. And I'll go ahead and write my compound, NaOCl. Oh, this is back to that question I made a comment about earlier. So this is sodium hypochlorite. And normally we write hypochlorite as ClO. But a lot of places, they write it in the order it is on the periodic table. So you will see hypochlorite written as OCl. It's the same thing. You can write it as NaClO. All right, and then we're going to put it over the volume that's given, 473.176 milliliters. There is a video that goes with the lab. The lab has a link to it, which should work, but I will, when I finally get done with everything at 3 o'clock today, I will hopefully put it on the playlist for Chem 151. But you just, I think it's like a 20 It's a 30-minute video, and you just watch it and do the lab, and then you'll have a bunch of calculations, lots of calculations. All right, can we change grams to moles? Yeah, that's using the periodic table. And it's always 1 mole. So again, that's the big point of today's lecture, is this is the periodic table. So go ahead and do it. And actually, I want to make a comment about your periodic table. I round sodium to 23, so 22.99, 22.98, depending on your periodic table, that's pretty much 23. However, magnesium, I do not round, 24.3. 0.3 can make a difference. So, right, like something like scandium, 44.96, that one you can round. But like barium, 137.3, I do keep the 0.3. So, yeah. Or you can do 22.99, doesn't really matter. So with that said, the chlorine, I'd never round it. I keep the full number for chlorine because it's smack in the middle. So don't round it to 35. So if you kept all the numbers from your table with 4 sig figs, 74.44, we're going to actually punch this in and get 4 sig figs. We'll change my answer. All right, so crossing out units. If you're getting stuck ever, cross out your units. That gets me to mole. I'm not using Avogadro's number here. You use Avogadro's number if the question says how many atoms, how many molecules. Avogadro's number goes with atoms and molecules. Avogadro's number does not show up on this page. Can we change milliliters to liters? Oh yeah, you guys are great at that. So either 1,000 milliliters or milli means 10 to negative 3. And so we want the liters in the denominator. Right. So quiet. Oh, it's pretty much 0.666. All right. So we're going to go with 4 sig figs. If you're using the periodic table with 3, then you're fine. I just wanted to go with 4 sig figs. So it's just when you do the lab, however, in the lab, and the first page of the lab, which is walking through it with me, you got to use 4 sig figs for all your numbers. That was kind of the point of the lab, because what I'm able to do, the scales allow us to keep 4 sig figs. All right, let's go ahead and do number 2. And so we have 2 pieces of information. Now, here we go. Which piece am I going to start with? How many of you have been drinking lots of coffee to stay up late at night? Making your own coffee. By the way, it is November, so I really enjoyed the healthy changes. I actually was thinking about that this morning on my morning meditative walk. This is actually the first time that anybody in Chem 151 has actually taken me up on it, and there were like, I think like 5 of you at least who did one, and they were actually impressive. They were some of the best ones I had from all 3 of my classes. There was somebody in each one of my classes who lost 10 pounds in the month, and I had a student who did all the change he did. It wasn't this term, it was in the spring term. He did the 3 pieces of fruit a day, and he kept it up, and over 3 months he lost 60 pounds. And then he went out to eat. The only place he was out in the middle of nowhere, and all they had in the town, it was a Prineville, was like a Burgerville. So he went out and got something at Burgerville, and he said he gained like 8 pounds in one meal from Burgerville, just because it's pretty much right. There's no such thing as healthy fast food. All right. So which piece of information do I start with? I was looking for my bonus point question. Anybody? Is anybody there?
Milliliters?
Yeah, so why? That was Damon.
It's a single unit.
Yeah, thank you. That was actually the whole point. Maybe Damon's the only one who's still here. But Damon actually sent me a wonderful email, and he said he always participates. He keeps getting these bonus points. But it's really helped him with chemistry. And so participating really can make a difference. So, and getting a bonus point here and there and keeps adding up is really nice. All right, when there are two pieces of information, you start with the one that has 1 unit. So you can draw your pumpkin underneath. I really need an orange pen. And this, again, cross out that M and think of it as moles per liter. That big M means moles per liter. I'm going to give you a word of caution. The big M has different meanings in chemistry. You got to keep it in context with what we're learning this week, which is moles per liter. All right, it is liters, which means our first step is go to liters. So when you're working with molarity, you have to be in liters. So milliliter is 10 to the -3, or however you do it. And then we bring this unit in, 0.015 moles to 1 liter. And great. And then we would do our mole to grams of KBr. So you'd look up K and BR and you get 119. So here we go. Damon doesn't get an answer and Maddie can't answer. I'll give somebody else a bonus point. Why does my answer have only 2 sig figs?
Well, in the 0.015, there's only 2 sig figs.
Yeah, who said that?
Alex.
Alex, thank you. So my other class, because they actually really participate, I give out a lot of bonus points in there. I had to make a new rule. So I have to figure out if you guys are up for the rule, which is when you answer a question, you actually have to put your camera on, because I have no idea who's talking. And when you put your camera on, I actually can see who's talking. But you got it, Alex. So I asked this question with this one because it's actually really important. It's a sig fig nuance that a lot of people miss. That 0 is not significant because it's a placeholder. So this number has only 2 sig figs. And that's why my answer can only have 2 sig figs. So whoever did the concentration of the KBr was not very precise. Just real quick over here, the 850 milliliters, this could be 2 or 3 sig figs. I'm going to put a question mark. It depends on who's teaching you. And unfortunately, Google teaches that it's 2 sig figs. And so everybody's just kind of reverted to that. That's not actually the rule. Without a decimal, we don't actually know if the 0 is significant or not. All right. I'm going to do these problems on Thursday. Because I know a couple of you can't be here Thursday, but that's the idea, and you know how to do factor label. The one thing I want to mention is you can actually, this moles per liter, if I ask you to solve for molarity, like on question 1, you have to solve for moles per liter. Same like when we did density. Density is mass per volume. But when you're using it in the factor label, it can flip upside down. And so if in this one, if this had flipped upside down, it would flip, so 1 liter would be on top, and the 0.015 stays with the mole. And so it can flip upside down to solve, but molarity is moles per liter. All right, any questions? I want to show you how to do empirical formula because some of you can't come on Thursday, and it actually, you might be able to, with what we did in lecture today, be able to do the lab. So the only thing due Thursday is the lab. So the lab has you walk through molarity, and then it has a lot of post-lab, which is refining how to do this. So we're going to do this question. We'll do one up there on Thursday. So empirical formula is the lowest ratio. All ionic formulas are empirical formulas. An example would be here. When we get to our answer, this is the empirical formula, Si2H5. It turns out that's not the actual formula. The actual formula is going to be Si4H10. But Si4H10 is not the lowest ratio. So this is a molecular formula, the whole compound. So molecules are not always the lowest ratio. So what we're going to do is how to do an empirical formula. And there's 4 steps, and we'll walk through it doing this example. Step 1 is you figure out your grams. And sometimes you actually know the mass. In this example, if it's given as a percent, so if percent is given, assume you have 100 grams in your sample. So all we do then is change our percent. So if our sample was 100 grams, then we have 91.80 grams of silicon. It's that simple. And then it tells you the rest of the sample is hydrogen. So to solve this, the other thing is we're going to solve it one over the other. So we're going to do a line of solving it for silicon and then a line of solving it for hydrogen. So we would just subtract from the 100, and so this must be 8.20 grams of hydrogen, so that the total of the two is 100. So that's the first step. It's a really simple step. The second step is the key, and it is why this is with this set of notes, is the theme of this. It's why there is a mole shown there. Is your second step. Does anybody want to guess what the second step is? The easiest bonus point of the year. Nobody's there. Yeah, the other rule is you only get 1 bonus point a class, but that's because like Damon got 3 in 1 class, and so I had to like have a cutoff at some point. Second step is go to moles. So change your grams to moles. That's the whole point of today's lecture. So we're going to change our grams to moles. And this step is from the periodic table. Now, if you clearly show your work, which you have to, because that's the whole point here, the units have to cancel out. So the hydrogen is 1.008, and silicon is right there, 28.09. So let's just go with 3 or 4 sig figs. Hopefully you made that choice. Make that choice. So you either say 28.1 or 28.09, and we're going to punch that in the calculator. Oh. And keep your sig figs. So for me, I'm keeping 4 sig figs, and it has a unit. It is moles. Or you can go to 3 sig figs. Don't round to 2 sig figs, or you're going to get weird answers. All right. So again, either 3 or 4 sig figs. Don't go more. More ends up being too much, and 2 ends up being too little. All right, step 3. Divide by the smallest mole. So 3.268 is a smaller number, so I'm going to do, you do to both of them, 3.268. With units. Please notice everything today, if we have a number, it has a unit. That is probably the most missed thing with empirical formula. Once you see how one works and you try one, you've got it. That's why there is a post-lab question. There's a whole page of doing empirical formulas. Once you get the key of doing it, you've got it. So one of them obviously is going to come out as 1. And then the other one will come out as some number, 3.268, which will give the answer with 2.489. All right. Questions up to that point? It's pretty straightforward. It's just these steps. Step 4 is really hard for me to explain. You have to multiply, you have to make whole numbers. So it takes experience to do this step. It's probably one of the most awkward things we do because there's not like this clear rule. I can say you just add the numbers from the periodic table, or this number means the number of protons, or you gain or lose. It just takes practice, which is why we're going to do practice. And it's recognizing that this is really 2.5 or 2.5. And I think the thing that's hard for students is knowing how much you can round. And it's at this step that you do have to do some rounding. So 2.489 is pretty much 2.5. So to make these whole numbers, we're going to multiply by 2. Because to make 2.5 into a whole number, if we multiply by 2, this pretty much gives us 5. You could do the same thing to both of them. This was a 1 to 2.5 ratio, which is a 2.5. And the reason they have to be whole is this is now the subscripts. I think I can spell. Meaning our answer is Si2H5. How to do that step just takes practice. So if you're pretty close to 0.5, round to 0.5. So 2.48, 2.49, 2.52, you should be getting really close to, so that's a half. You could be multiplying by 3. So that would be if you have 0.33 or around 0.33, because 0.333 is a third, or 0.666, 0.667, because that's 2/3. You can multiply by 4. You would multiply by 4 if it's 0.25, so 1/4. And again, it takes practice. We just have to do a couple of these, and that's what the last page of your lab has a couple of those to try, and we're going to do another one here. Let me go through B. And so the trick with this is it is the molar mass, which has to be given to you, divided by the empirical mass. So you were given the 122. AMUs stands for atomic mass units. It is the same thing as grams per mole. It's the same thing. So the empirical mass we get because we know that our empirical formula is Si2H5. So we find this from the periodic table. So you're going to add up your 2 silicons. And here you can do more sig figs, but I'm going to round to whole numbers because this is rounded to a whole number. It's like my silicon is, right, 20 times 2 plus 5. So I get around 61 grams per mole. So that was just using the periodic table to add up the 2 silicons and the 5 hydrogens. And 122 divided by 61 is 2. What that means is there are 2 empirical formulas in the molecular formula. So I double it. So what is wrong to do is we don't say we have 2 SiH5s, Si2H5s. That is not correct. Our answer is 2, and it means we double the subscript. If you get 3, you triple the subscript. And so that's why I end up with Si4H10. These are always whole numbers. That's the key of that last step, is to make it a whole number. And again, it just takes practice. Questions? All right, let's go ahead and try this last one. So, make your list. Instead of writing percent, write it as grams, carbon, 5.30 grams of hydrogen, and then the rest is oxygen. So again, I put an X through the oxygen, or students think it's a 0. So to find my grams of oxygen, what am I going to do? My calculator.
Add the other 2 and subtract it from 100?
Yes. So I got 31.55. So these numbers, these had to equal the 100 grams because it was a percent. So percents are out of 100, so we just have to make these equal 100. That's a 5.5. All right. Next step is go to moles. So let me give you a moment to go to moles. And I will write down, I got Alex, that was Stephen. I think.
Yeah.
You have a yellow box around you, so I'm assuming that was you who talked. All right, so change your grams to moles. Do it for each one, and then divide by your smallest number. Wish there was like an easier way to pause this, but. I'll tell you, my biggest pet peeve as a chemistry teacher is students writing numbers without units. So you can just write mole. The carbon is right here, and so I know this row is going to be all about carbon. My next row is going to be all about hydrogen, and my last row is going to be all about oxygen. And again, these numbers are coming from your periodic table. Always look at the number, but we do so much with carbon, hydrogen, and oxygen because we're organic beings, which means we're made up of carbon, hydrogen, oxygen, that you just start knowing these numbers. You would hope your chemistry teacher knows them. When you get those, divide by the smallest one. So go ahead and go through it, or sit here and stare at me for a minute. I do find students who do, hopefully you had your calculator with you. If not, you should really be in that habit, having your calculator. and your periodic table. Right, the hydrogen comes out the same. The biggest problem students have with empirical formula is one, that they never do it, they never try it. So you have to do the work. If you do the work, it becomes no problem. And then the other problem is rounding too much. So I like 4 sig figs. 3 should work fine. And then we divide by the smallest. So you can actually show it, or yeah, the 1.972. All right, so there we go. Now, if you're doing your math right, you should be able to get to a number that you can, I am fortunately blessed. I see this as a fraction. I learned it in 4th grade, and whoever my 4th grade teacher was who taught, well, 3rd grade you learn fractions, 4th grade you learn decimals. However they taught it, I visually can see it. And so I see this as a fraction, as a percent, as a decimal, all at the same time. And so this is really, right, 2/3. So it's really 2 2/3. So you're multiplying by this number, that denominator. 2/3, you're going to multiply by the 3. That's how you make it a whole number. So we're going to multiply all of these by that 3. And you'll get 8, 8, and 3, including the last one. And that's where my ratio comes from, C8. Our final answer is C8H8O3. And that's the idea. And so, Stephen, you should be able to do the whole lab now with what we got through. There you go. See, I pushed
when
through
you
it.
say you multiply it by 3, what are you multiplying by 3?
The 2.666.
Oh, okay.
And you get 7.9994. So you say
You
8.
always round to the whole number.
Well, yeah, 7.999. Yeah, you can round it to 8. So the mistake students make is when they round too much. So they say this is 2.6. You're not going to see the 66. So 0.33, 0.66, that is 1/3 or 2/3. So this is why there's that extra page in your lab, to give you guys practice with these. And so it should come out. You shouldn't be multiplying. Sometimes they come out as whole numbers. When you do the last step, you're doing the molar mass over the empirical mass. So you need to label the step. So it's the 152.14, and AMUs is the same as grams per mole. When you add up the C8H8O3, you pretty much get 152-ish, whatever, that same thing. So it comes out as 1. This is an awesome, when you have part B, it's really nice because it means you got it right, because you should get a whole number. And so getting a 1 means the empirical formula and the molecular formula are the exact same. So our answer is still C8H8O3. This must have been vitamin C. Oh yeah, it was the scurvy question. I actually have a friend who had scurvy like 6 months ago. I didn't know people actually got scurvy. You just need to eat your 3 pieces of fruit a day for the month of November, and you get bonus points and you'll feel a lot better. First week is hard, but then you never go back. Any questions? And again, Stephen's question was really important, that knowing what to multiply by. That's the key, and it takes practice. And we'll finish up the notes on Thursday, and I have more office hours Thursday, or I have office hours this evening if you have questions on today's lab or quiz. If not, I'm going to stop and you can take off.